Today we're going to be talking about functions. At the end of the video, I would like you to return to this page and look at the 8 graphs and determine which are functions and which are not. Two of the vocabulary words that we'll be using are functions and relations. A relation is a set of ordered pairs, that is an x and a y, like here, where x represents inputs and y represents outputs. This is set notation when you have the squiggle bars, the braces. I'm not very good at writing braces, but a relation is a group of ordered pairs. A function is a set of ordered pairs whose x values never repeat. The vertical line test is a way to test to see if you have a function. That's one of the tests that we will be using. It is a method for determining whether a relation is a function or is not a function. Function notation is simply using f of x in place of y. Y and f of x mean the same thing. It's kind of like your first name and your middle name. They both mean you, but you can call someone by their first name or by their middle name. In Algebra 1, we use y most of the time. But from here on out, you're going to see f of x a lot. So we need to start getting used to it. The domain, one of the most important words in algebra, is the set of all x values, all possible x values. And the range is the set of all possible y values. X values are inputs and y values are outputs. Think of a car. You input gasoline and you output driving. So when we need to determine if a relation is a function, we want to see if any of the x values are repeated. For example, if we look at 0 here, we can draw an ordered pair of 0, 4. We can draw an ordered pair of 0, 8. I already know that this relation is not a function, because if I put in 0 for x, I could get 4 for y, or I could get 8 for y. And that means it is disqualified from being a function. The other two ordered pairs are 5, 6 and 10, 1. But when the x repeats and you have different y's, it is not a function. So, is this ordered pair, is this relation a function? Yes, it is, because x does not repeat. Here's your first U-try. The question is the relation a function? One of the methods that we can use to determine whether a relation is a function is something called the vertical line test. If we had a piece of paper and a pencil, we could draw a line or just lay the pencil across the line and then roll the pencil across the paper. And if we ever find that the pencil is covering up more than one point at a time while it is in a vertical position, then that relation would not be a function. Is this one a function? Vertical line test, that's not a very good vertical line, but the vertical line test would say no. Is this one a function? Yes, because whenever I draw a vertical line, I'm only touching one point. Here is your next U-try. Which of these graphs are functions? Use the vertical line test. Record your answers. Remember, we have said that y and f of x mean the same thing. This is the one time that parentheses do not mean multiply. This is read f of x, not f times x. It means the value of f at x, and the value of the function depending upon which x you input into the function. So x is the independent variable. It is the variable that you will put into the equation, and y is the dependent variable. So f of 0 means I'm going to put 0 in place of x. So I get 5 times 0 plus 1, which is just 1, because 5 times 0 is 0 times anything is 0. If I put 3 in, I will get 5 times 3, which is 16. And if I put negative 2 in, I will get 5 times negative 2 plus 1, which is negative 10 plus 1, which is negative 9. That's solving for y in function notation. Here is your U-try. Solve for y, or f of x. Remember, y is equal to f of x. They mean the same thing. And when you have f of 0, 0 is in the place of x, so 0 goes in the place of x. Domain and range are very important vocabulary words. In algebra, you will be talking about domain and range for several years to come. Domain means the set of all possible x values. What are all the x values possible? And that's why we have learned interval notation, because we do not want to sit in our chair and write down all the x values when x goes from negative infinity to 4, for example. But when x is very limited, we can use braces. And we can see that the x values here are 2, 4, 3, 6, and 5. And we can see that the y values, or the range, are negative 3, 6, negative 1, oh, 6. Do I have to write 6 again? No, I don't. And 3. The range is the set of all y values. The domain is the set of all x values. So what would be the domain of the following relation? Domain would be negative 3, negative 2, negative 1, 0, 1, and 2. And the range would be 5. Hey, 5, 5, 5, 5, 5, 5. The only thing in the range is 5. Do I need to write it over again? No, I just write it. Here's your U-try for domain and range. Determine the set of x values and the set of y values. All right, that's pretty much it. We will go over everything in class. Make sure you bring your questions. Function notation, domain and range.